Now let's start representing rational numbers on the number line. Now first of all, we have natural numbers. So let us see, where do we find natural numbers on the number line. So if you mark the points at equal distance on the number line, we can mark them as 1, 2, 3, 4, 5, 6 and so on. So these are natural numbers that we represented on the number line. If we want to represent whole numbers on the number line, we will mark one more point before 1, that is 0. So with the introduction of 0, we get whole numbers on the number line. If we want to represent integers, we will also write the negative counting numbers. But remember one thing, all these numbers should be equally placed. They should be placed at equal distance from each other, both on the right side of 0 and on the left side of 0. So this way we have represented integers on the number line. Now let us see how to represent rational numbers which are in the form of p by q on the number line. So there can be two types of numbers. If I take p by q, first case can be p is less than q. Second case, when p is greater than q. Now let's, for example, take a number where p is less than q. Let us take 2 by 3. How to represent 2 by 3 on the number line? Remember one thing, whenever the numerator of a rational number is smaller than the denominator, that number will always lie between 0 and 1. Suppose if I divide 2 by 3, what do you get? The decimal representation is 0.6 and bar basically. So it will go on and on. So 2 by 3 is actually equal to 0.6 bar, which is definitely less than 1 and greater than 0. So this number 2 by 3 is definitely going to lie between 0 and 1. It means this is the portion in between these two numbers 2 by 3 is going to lie. That much is clear to us. Now exactly where it is going to lie. So 2 by 3 means I can read 2 by 3 as 2 out of the 3 parts of which place? This, the number between 0 and 1. It means first I want to divide the space between 0 and 1 in 3 equal parts, and that can be done by putting 2 dots. So after putting 2 dots, I have got 3 equal parts of this region between 0 and 1, 1, 2, 3. So I want to represent 2 by 3 means 2 out of the 3 parts. So 1, 2, this is the second part. So I can say this is representing 2 by 3 on the number line. Now let's take one more example of representation of a rational number in the form of p by q, where p is less than q. Let's for example take the number 3 by 5. How to represent 3 by 5 on the number line? Here p is less than q, 3 is less than 5. That means that number is going to lie between 0 and 1. Why 3 by 5 is greater than 0? Because it is a positive number. Had it been a negative number, it would have gone on the left side of 0. So right now 3 by 5 lies between 0 and 1. Now let's see how we are going to represent 3 by 5 on the number line. So suppose we mark the points 0, 1, 2. You can adjust the gap between two numbers. You can take any scale to represent these numbers, not necessarily that at a gap of 1 centimeter only you have to take. You can take these numbers at a gap of 1 inch. Okay. Now 3 by 5. I can read 3 by 5 as 3 out of the 5 parts of which portion? Definitely when we have decided that 3 by 5 lies between 0 and 1. On the number line between 0 and 1, this is the portion between 0 and 1. And I have to represent 3 out of the 5 parts. So obviously this is the portion which I have to divide into 5 parts, and then I will take 3 parts out of those 5 parts. So in order to divide this into 5 parts, I will mark 4 dots, 3 and then 4 at equal distance. Now these are the 5 parts, 1, 2, 3, 4, 5. I have to choose 3 out of them. 1, 2 and this is 3. I can say this point represents 3 by 5 on the number line. Suppose now next I take a number p by q where p is greater than q. For example, now let us take 5 by 3. Here p is greater than q, that means 5 is greater than 3. So definitely this number will not lie between 0 and 1. So the first thing we have to do is to check where exactly it lies on the number line. So 3 ones are 3 and 2 remainder point, and then we get 3 6 are 18. So approximately we get 1.6, or if I want to write it in the mixed fraction I can write it as 1 2 by 3. This is a better way of representing. So first you write the number in a mixed fraction form, 1 2 by 3. Now looking at 1 2 by 3, what do you understand? That it lies between which two numbers? 1 and 2. So that is 1 2 by 3 will definitely be greater than 1 but less than 2. So on the number line it will lie between 1 and 2. This is the part 1 and this is 2. So it will lie between 1 and 2. Now this 1 complete number is already represented from 0 to 1. 2 by 3 is to be represented between 1 and 2. So how many dots I have to put? 3. 3 parts I have to divide, so I will put 2 dots only, because now I have to represent 2 by 3 between 1 and 2. So 2 out of the 3 parts. So 1 complete number and then 2 by 3. So that makes it 1 2 by 3, which is actually equal to 5 by 3. That is the representation of 5 by 3 on the number line. Let's take one more example. Say I say 7 by 3, suppose. So let me first convert 7 by 3 in mixed fraction. 3 2s are 6. And so what do I get? 2 1 by 3. The mixed fraction is 2 1 by 3. So where exactly 2 1 by 3 will lie on the number line? 2 1 by 3 will definitely be greater than 2 but less than 3. That means, suppose I mark the points 0, 1, 2, 3, 4 and so on. Similarly, you can mark the negative numbers also on the number line while representing. Now 2 1 by 3. This 2 complete number can be shown from 0 to 2 here. After that we have 1 by 3. That has to be shown between 2 and 3. That 1 by 3 part has to be shown between 2 and 3. So what is the meaning of 1 by 3? I can read it as 1 out of the 3 parts of this portion. So in order to divide this portion into 3 parts, how many dots I have to put? I will put 2 dots, 1 and 2. So it has been divided into 3 parts. Out of these 3 parts, I have to choose one part. So this is the first part. So this is representing 1 by 3 here. And 2 we have already represented from 0 to 2 complete number. So 2 1 by 3 will be this number, which is actually equal to 7 by 3. Now the last example we take is of say 16 by 5. Now what is a mixed fraction form of 16 by 5? As you know, 5 3 is a 15 and 1 is the remainder. So we can write it as 3 1 by 5. 3 1 by 5 is the mixed fraction notation for this number. Now let us see how to represent this number on the number line. So from here it's very clear that 3 1 by 5 actually lies between 3 and 4. So let's start marking the numbers 0, 1, 2, 3, 4, 5 and so on. Similarly, you can mark few negative numbers as well if you want. Now 3 1 by 5 lies between 3 and 4. That means this 3 complete number is represented on the number line from 0 to, this complete number is 3 is represented between 0 and 3. So this number is representing 3. After 3 I have to represent 1 by 5 between 3 and 4. So 1 by 5 means 1 out of the 5 parts of the portion between 3 and 4. In order to divide this portion into 5 parts, I will put 4 dots. 1, 2, 3, 4. And I have to take one part out of it, which is this. So I'll get 3, 1 by 5, which is equal to 16 by 5. So this is how we represent rational numbers on the number line. Now children, let us see how to represent irrational numbers on the number line. Let us first of all take the example of irrational number root 2. Now the procedure is, first of all, take the number inside the radical sign and try to write it as the sum of the squares of two natural numbers. In this case, 2 can be written as 1 square plus 1 square. So just concentrate on these two numbers, 1 and 1. So we have to take 1 unit on the number line and 1 unit perpendicular to it. Suppose I mark a point 0 here, and this gives my 1 unit, and similarly I have to make 1 unit perpendicular to this, perpendicular. Now when I say 1 unit, it's up to you to decide the scale, that what is your 1 unit. You can take 1 unit as equivalent to 1 inch, or if you want you can take 1 unit as 2 centimeter, 3 centimeter, 2.5 centimeter. It is up to you, but then you will have to follow that scale throughout the number line. You can't change that scale in between. So because we had written 2 as 1 square plus 1 square, so we are just concentrating on these two ones. Because both the numbers are 1, so we take 1 unit on the number line, 1 unit perpendicular to it, and join these 2 points. Now in triangle OAB, because we have taken perpendicular, so triangle OAB is a right angle triangle. So in right triangle OAB, if I use Pythagoras theorem, what do I get? OB square is equal to OA square plus AB square. Now what is OA? It's 1 unit, so 1 square. AB is also 1 unit, so 1 square. That gives me 1 plus 1, which is 2. So we get OB square as 2, or we can say OB is equal to square root 2. It means the length of this OB is equal to root 2 units. So now you can say we have measured what is root 2, that is from O to B the length is root 2, but we have to represent root 2 on the number line. So what we do is, we take a compass, keep the pointed end of the compass at the point O, take OB as the radius and draw an arc which will intersect the number line at some point, say C. Now if you look at OB and OC, are they equal? Because if I suppose complete the circle, then OB and OC will become the radii of the same circle, hence they will be equal. So if OB is root 2, OC will also be root 2 units. It means on the number line, point C represents root 2. Now children, if I take the next number as root 3, 3 cannot be written as the sum of the squares of two natural numbers. 3 can be written as 2 plus 1, where 2 is not a square of any natural number, where 1 can be written as a square of 1. So these type of representations we will take up later on in the second type. So right now the number which I am going to choose is root 5. Now if I take 5, it can be written as 4 plus 1 or 3 plus 2. There are two ways of writing 5. But let us see which one should we opt for. 4 is the square of 2, 1 is the square of 1. In this case, 3 is not a square of any natural number, 2 is not a square of any natural number, so we will not go for this option at all. We will not go for this option. We will go for 4 plus 1, which is 2 square plus 1 square. So now we are going to concentrate on these two numbers, 2 and 1. So on the number line, we will first mark the numbers 0, 1, 2, 3 and so on. Now I have to take 2 units on the number line from here till here. It's 2 units on the number line and 1 unit perpendicular to it. These are 2 units from here till here, and this is 1 unit perpendicular to this. And when I join these 2 points, a triangle is completed, a right triangle. So again, in right triangle OAB, if I use Pythagoras theorem, I will get OB square is equal to OA square plus AB square. So that is equal to OA is 2 units, so 2 square, AB is 1 unit, so 1 square, which is equal to 4 plus 1, which is equal to 5. So we get OB as root 5. So again, I have already got root 5 is OB, but I want it on the number line. So what will I do? I will take a compass, keep the pointed end of the compass at the point O, take OB as the radius, this one, and draw an arc, and that will intersect the number line at a point, say C. So again, OB and OC are equal, and hence we can say because OB is root 5, so OC will also represent root 5 on the number line. That is, point C represents root 5 on the number line. Now children, remember one thing, when we wrote 5 as 4 plus 1, which is 2 square plus 1 square. Now it is not necessary that you have to take 2 units on the number line only. You can even change it. Suppose I can do it this way. I can take 1 unit on the number line and I can take 2 units perpendicular to it. Say this. And then I join these two. So this is OAB, right triangle. Now taking O as the center, OB as the radius, if you draw an arc, again you will come to know that OB and OC are equal and C represents root 5 on the number line. I mean to say, whenever you write the number as the squares of 2 natural numbers, then those 2 natural numbers, one of them has to be taken on the number line, the other one has to be taken perpendicular to it. Now let's take another example, say 8. Again with 8 I have so many combinations. I can write it as 7 plus 1, 6 plus 2, 5 plus 3, 4 plus 4. Out of these 4 options, 7 is not the right option for us because 7 is not a square of any natural number. 6 plus 2 is also not the right option because 6 and 2 both are not the squares of any natural numbers. Similarly, 5 plus 3 is not good for us, but 4 plus 4, yes it is. 8 is equal to 4 plus 4, which is equal to 2 square plus 2 square. So now we have two numbers with us, 2 and 2. So what will I do in this case? Again, when I draw a number line, I will take 2 units on the number line and 2 units perpendicular to it. It has to be a straight line perpendicular to the number line. So when I join this, OAB. So this is 2 units, this is 2 units. By using Pythagoras theorem, we get OB as root 8 units. So again, taking a compass and drawing an arc, we'll get a point C here. So OB and OC are equal and hence point C represents root 8 on the number line. After root 8, let's take any other number, say root 13. Again, try to express 13. The best possible combination for 13 will be 9 plus 4. You can check out for the rest of the combinations, they will not work out. The best combination is 9 plus 4. Why? Because 9 is the square of 3, 4 is the square of 2. So we are able to write both the numbers as the squares of two natural numbers. Now let us see how to represent root 13 on the number line. So on the number line, I will first take, now as I told you earlier, the two important numbers for us are 3 and 2. So either I will take 3 units on the number line and 2 units perpendicular to it, or vice versa, means I can take 2 units on the number line and 3 units perpendicular to it. Both ways it will work. So I am starting with 3 units on the number line. So this is 1, 2, 3. These are the 3 units that we have chosen on the number line, and perpendicular to it we will take 2 units. That means 3 units here and 2 units perpendicular to it. When we join these 2 points, let's name this point as B and this is A. So if I use Pythagoras theorem here in triangle OAB, what do I get? OB square is equal to OA square plus AB square. So what do we get here? It is 3 square plus 2 square, which is equal to 9 plus 4, that is 13, and hence OB is equal to under root 13. So if root 13 is OB and we want to represent it on the number line, so what we do, taking O as the center and OB as the radius, we will draw an arc intersecting the number line at a point, say C. Now OB and OC being the radii of the same arc or the same circle, they will be equal, and if OB represents root 13 on the number line, if OB represents root 13, OC will also represent root 13. So point C represents root 13 on the number line. Now let us take type 2 numbers. For example, say under root 6, if I want to represent, 6 can be written as 4 plus 2, which is 2 square plus root 2 whole square. Now the two important numbers for us here are, one is 2, another is root 2. Obviously we cannot measure root 2 on the with the help of a scale, because it is an irrational number and it is a non-terminating and non-repeating decimal. So we have to take root 2 on the number line and 2 units perpendicular to it. Okay, so how to represent root 2 on the number line? We take 1 unit here, 1 unit perpendicular to it. This you have already done. The very first question that we did was root 2 only. So the same method I am following for representing root 2 on the number line. Suppose this is the point which represents root 2 on the number line. I name this point as A. So this part we have already represented on the number line. Now let us take the other one, which is 2 units. So from point A, I will mark 2 units perpendicular to it. So if I join this point B with O, I will get the right triangle OAB. Now in right triangle OAB, by Pythagoras theorem, again I will get OB square is equal to OA square plus AB square. That is equal to, now OA is root 2 units and AB is 2 units. So we will get 2 plus 4, which is equal to 6. Hence OB is equal to root 6. If OB represents root 6 units and you want to bring it down to the number line, what we do, we'll take O as the center and OB as the radius and draw an arc intersecting the number line at a point, say C. So OB and OC being the radii of the same arc or the same circle, the lengths will be equal. If OB is root 6, OC will also be root 6, and hence C represents root 6 on the number line. Let's take one more example of root 11, representation of root 11 on a number line. Now 11 can be written as 9 plus 2. Children, here I am writing the best possible combination. You can try out the other combinations and you will find this is the best one which you can opt for. So 9 is a square of 3. 2 is not a square of any natural number, so we write it as a square of under root 2. So now the two important numbers with us here are 3 and root 2. So as I have already told you, here we don't have an option of taking any number on the number line and any number perpendicular to it. Here, because root 2 cannot be measured with the help of a scale, this being a non-terminating and non-repeating decimal, we have to represent root 2 on the number line first, and then we will take 3 units perpendicular to it. So you all have understood by now that how to represent root 2 on the number line. We take 1 unit here, 1 unit perpendicular to it, join them, draw an arc, and here we get root 2 on the number line. Now the other number is 3. So we will take 3 units perpendicular to it, 1, 2, 3. This is 1, 2 and 3 units perpendicular to root 2. Join them and name this point as B. So OAB being the right angled triangle, if I apply Pythagoras theorem here, I will get OB square is equal to OA square plus AB square. Now OA is equal to root 2 and AB is equal to 3. That gives me 2 plus 9, which is equal to 11. Hence OB can be written as root 11. If OB is root 11 units, again what I can do is, taking O as the center, OB as the radius, I can draw an arc which intersects the number line at a point, say C, and this point C, like OB and OC will be equal, they being the radii of the, see you can very easily see OB and OC being the radii of the same arc or of the same circle, they can be, they will be equal. So OB is root 11, that means OC is also equal to root 11. Hence point C represents root 11 on the number line. Yes children, there is one more way of representing irrational numbers on the number line. Just pay attention. I can write 2 as 1 plus 1, which is equal to 1 square plus 1 square. 3 can be written as 2 plus 1, which is root 2 square plus 1 square. 4 can be written as 3 plus 1, which can be written as root 3 square plus 1 square. 5 is equal to 4 plus 1, which is equal to root 4 square plus 1 square. I hope you are understanding the pattern that I am using here. Root 5 square plus 1 square. Now suppose we have to represent various irrational numbers on the number line. What I do is, first of all, suppose I have marked a point 0 here. This is 0. Then I have to take 1 unit here and 1 unit perpendicular to it. This all of you I think have understood now. When I join these 2 points by Pythagoras theorem, when you calculate, this comes out to be root 2 units. Now when I draw an arc, it intersects the number line at a point, and that point we say represents root 2 on the number line. Now for representing root 3, we have taken the combination of 2 plus 1, which is equal to root 2 square plus 1 square. It means I need to take root 2 on the number line and 1 unit perpendicular to it. So root 2 on the number line is represented by OA. This length gives you root 2. Now on OA, if I draw perpendicular line of 1 unit, and join it to the origin. Then by Pythagoras theorem, OA is equal to root 2 and this length is equal to 1. So by Pythagoras theorem you will get it to be equal to root 3. I hope you understand, or you just look at the working here. In right triangle OAB, by Pythagoras theorem what do I get? OB square is equal to OA square plus AB square. OA, as you know, is root 2 and AB is 1. That gives you 2 plus 1, which is equal to 3, and hence OB is equal to under root 3. If OB is root 3, again with the help of an arc I can draw here, and it meets the number line at a point, say C. So point C will represent root 3 on the number line. Similarly, if I take one unit perpendicular to this and join it and draw an arc, I will get under root 4 by using Pythagoras theorem only. Again, if I take one unit perpendicular to it, join it to the center by Pythagoras theorem, again I will get this length to be root 5 and so on. But the problem here is, suppose you have to represent root 17 on the number line, and if you will keep on representing each number 1, 2, 3, 4 up to 17, it is going to be a very lengthy procedure. So what we do is, as I told you previously, that 17, write down the best combination for 17, that is equal to 16 plus 1, that is equal to 4 square plus 1 square. So now we have two numbers with us. We take 4 units on the number line, 1 unit perpendicular to it, and we are able to represent root 17. If you have to represent root 13, we take it to be 9 plus 4, that gives me 3 square plus 2 square, rather than taking 13 as 12 plus 1, which will be root 12 whole square plus 1 whole square. So first you have to show root 12 on the number line, and then taking 1 unit perpendicular to it will give you root 13 on the number line. So what is the best way? Writing 13 as 9 plus 4 and not as 12 plus 1. Now, yes, with the help of this procedure we can create a square root spiral like this. As I told you that for representing root 2 on the number line, what do? We just take 1 unit on the number line, 1 unit perpendicular to it, join it. We get this length as root 2. Suppose I name this point as A1, this is A2. So by Pythagoras theorem, all of you know OA2 represents root 2 on the root 2. Then I take, instead of bringing it down on the number line, what I do is I take 1 unit perpendicular to OA2 only and I join them. So what will it give me by Pythagoras theorem? This will give me root 3. Now if I take 1 unit perpendicular to root 3 and join it to the point O, it will give me root 4. Again taking 1 unit perpendicular to root 4 and joining it to O will give me root 5, all by Pythagoras theorem. Again 1 unit perpendicular joining it to O will give me root 6 and so on. And children, you will observe, when you will keep on doing it like this, you will ultimately see that it is going to be, we go on and on, you are going to get a spiral of this kind. Okay, so I have just explained you, and today we are going to send you a video which will explain you this spiral completely. What you are supposed to do it, you have to draw it on an A4 sheet, and after watching that video, and keep it safely in your portfolio. You know, your portfolio files are there, so you just keep it safely and we will include it in your portfolio work. Okay.